All right, guys, I am going to try to do this both efficiently as I'm trying to, how would I say it? Sorry. Uh, I'm trying to ride the line between too much and too little always. Okay, so hopefully I'm giving you the right amount. If you need to have a second look at this stuff, you can always like go back and watch the problem again. Okay, I think for each of the topics I have two. Okay, so for this one, they are just trying to get you to understand the ratios. Okay, so for each triangle, well, the ratios in similar triangles. Do you guys see that these are similar? They all have the same angle. Okay, this is a really cool thing. This is basically simply creating three similar triangles. Okay, and they're going to compare the ratios of the same sides. So, in other words, BC opposite over AC, hypotenuse. So you would go 4.8 over 7.3. And then you would put that in a calculator, round to the nearest hundredth. Okay, EF would be 19.2 that you would plug in over 29. Whoa. Oop, 29.2. And YZ is 33.6 over 51.1. And what you will find out is that these are all the same. Okay, I can actually grab a calculator. Well, I don't really want to do it because I don't feel like that's helpful, but I don't know. Maybe it is. Maybe it is. Maybe it is. 4.8 divided by 7.3. Let's try this. Okay, ready? 4.8. Ooh. Okay. 4.8 divided by 7.3. Okay, so you get 0.6. It said nearest hundredth, so that's 0.66. Okay, so what you're going to get is 0.66 for each one of these. Okay, and then notice that's the ratio of sine. That's opposite over hypotenuse. On every single one, it was the opposite over the hypotenuse. So look, now they want you to put in there sine, cosine, and tangent. So in your calculator, you're going to put tangent of 41.1. And you'll get 0.2652. Okay, cosine 41.1, and then you get this. Okay, then you get sine 41.1, and lo and behold, wait a minute. Hang on. The sign of a positive is not. Why is this coming out negative? Ooh, it's in radians. Oh my gosh, this is really important, you guys. Do you see how RAD is dark? Degree. Your calculator needs to be on degree. Make sure that it is. Okay, it'll say DEG on the top. Okay, so I was like, that can't be. That makes no sense. So sine 41.1, and look, it's 0.66. And look, if we go back here, it's 0.66. So you would get different values for cosine and tangent. But what they want you to recognize is that that trig function is sine. Opposite over hypotenuse is sine. Okay. Next. So now look, now they're taking EF over, oh, this is the same one, dang it. Okay, so this is the same one. I'm not actually going to do that. I think that this is pretty self-explanatory. You won't have trouble with that one. Okay, relationship between sines and cosines of complementary angles. All right, remember complementary means, by the way, I better lock these down. Complementary means add up to 90, okay? These are the two complementary angles, okay, X and Y. They add up to 90 degrees, okay? So first part, use X, Y, and Z, okay, to fill in the blanks. So look, take a look. Opposite of X is little x. Opposite of Y is little y, right? Okay, just want to make sure you recognize that because for some reason I've had trouble with that in the past. All right, so what is the sign of X? Look, opposite over hypotenuse, X over Z. And look, what is the sign of Y? Okay, the sign of Y is Y over Z. Okay, so then they want cosine of x. This is still part one, you guys. It's like I had to copy it over here because it was too long. Okay, so this one was x over z, and this one was y over z. And then look, if you get cosine of x, you're going to get y over z. And if you get cosine y, you get x over z. And what they want you to recognize is that the sine of x is equal to the cosine of y, and the cosine of x is equal to the sine of y. Okay? And so it says, part two, choose in triangle XYZ, angle x and y are, and I'm pretty sure you're going to put complementary. Okay? Check all of the true. Is sine x equal to sine y? No. Is sine x equal to cosine y? Yes, it is. Sine x, cosine y. Okay, and cosine x is equal to sine y. All right? Fill in the blank. So this is the part that might be a little harder. It says sine of 58, they're trying to get you to realize what you could do, is equal to the cosine of, okay, all you have to do is take 90 minus 58, because you're going to do the complementary angle. So that's cosine of 42 degrees. Nope, that's not right. That's not right. 32. 32. 32. Okay, 32. Cosine of 32 degrees. Boop. There we go. All right, yeah, and that's always the case. So like the sine of 60 is equal to the cosine of 30, because 30 and 60 add up to 90. That's just the way it is, okay? All right, next. So again, I didn't do a second one because I figured you could do that, okay? Now it says find cosine, sine, and tangent of z. Round your answers to the nearest hundredth. So now you are using a calculator. So these are pretty easy, okay? Remember, put yourself at location z. Okay, now wait a second here. Okay, they haven't, oh, you know what, I'm missing the top. Okay, because I had to cut it because I needed these. These are similar triangles. Okay, so what they want you to do is figure out which point corresponds to z and then use it. Okay, and in this case, z corresponds to b. So then you're basically going to go ahead and just use b as your location. Okay, so cosine of z is going to be the same as cosine of b because they're similar triangles. Okay, and cosine is equal to adjacent over hypotenuse. Just identify your hypotenuse. Opposite, there you go. Okay, so cosine is 12 over 17.4, and you put that in the calculator round to the nearest hundredth. Sine of z is going to be opposite, which is, 12.6 over 17.4. Sorry, I ran out of room. And the tangent is equal to opposite over adjacent, 12.6 over 12. Plug them into the calculator, round to the nearest hundredth. Okay, I have a feeling this one's going to be pretty easy for you. All right, this one I'm not going to go ahead and do all of it. All I'm going to do is help you see what the real problem. See how it says XYZ is similar to BAC? They actually tell you X, Y, Z, B, A, C. So they're flipping it around. So it says find sine C, tangent C, and cosine of C. So you can see that C corresponds with Z. Okay, because it's of the same order. See? B is with X. Yeah. Okay, so C corresponds with Z. So go ahead and there you go. This is opposite, hypotenuse, adjacent. And then you would just find these. I'm not going to go over them. I tested you guys. You did well. I don't think you need to copy this down in your notes. Okay, now this is where we get into a little bit more useful applications of trig. Okay, it says solve. Okay, actually using trigonometric ratio to find the side length in a right triangle. Okay, so this is the beginning of actually using trig for real purposes here. Okay, so what you want to do is you've got an angle. Okay, you can figure out the other angle and stand there if you wanted to, but since they gave you this one, it's just easier to stand here. Identify the sides. Shoot your arrow you've got the opposite, and you've got the adjacent. Which relationship? This is your next question. Okay, so toa. Which relationship do you have here? Okay, you have opposite and adjacent. And the one function that uses opposite and adjacent is tangent. So now you're going to write a sentence, write a true sentence using this angle. So we are going to say the tangent of 31 degrees because we know the angle. We're not going to put a variable because we know it is right there, is equal to x over 8. So now we're looking for the side length, okay? Just use your proportions. You know how to solve this. Get rid of the denominator. You don't like a denominator? Get rid of it. And that's what you plug into your calculator. Look, practice it at home if you need to. It's 8 times, and make sure we're in degrees, 8 times tangent of, was it 31? Sorry, you guys, I feel like I have the memory of a fish right now. Okay, it was 31. Okay, 31, tangent 31. Okay, and there you go, 4.8. That is the length of the side. Usually they have you round sides off to the nearest tenth. Yep, there it is, nearest tenth. And that was 4.8. Oh, so it's 4.8, and that's it. So the main thing you have to get from here is which function to use, which trig function to use, and then just use algebra to solve for x. So here we go. Let's look at the next one. Okay. Again, round it to the nearest tenth. Here's your angle. You have this angle. So here you are. You're just sitting here. Hello, I'm sitting here. Okay, opposite. We have opposite and we have adjacent. By the way, they really like tangent in general. So that is the tangent again. So you're going to write tangent of 20. I believe that's what it was. Yeah, tangent of 20 is equal to 20 over x. Now we want to solve for x, okay? And x, that's a problem because x is on the denominator, okay? So we're going to multiply both sides by x to get rid of, well, to bring it to the top. Then write what you have. You have x tan 20. Now, the biggest mistake kids make is they try to separate the tangent and the 20 degrees. Remember, tangent, sine, and cosine do not exist without an angle. These guys are stuck together like glue, okay? The tangent at 20, it's stuck. Okay, you cannot divide by 20. That doesn't make any sense. The tangent of 20 is a value. So it says x times tangent of 20 equals 20. Well, we don't want x tangent of 20. We want x. So what do you want to get rid of? Go through your solving. What do you want to get rid of? Tangent of 20. Okay, what is it doing to the x? Multiplying. Okay, and then how do you undo multiplication? Division. And there you go. X is equal to 20 divided by the tangent of 20. So when you go to your calculator, okay, you're going to go x, 20 divided by tangent 20 equals 54.94. Okay, and that is the length of the side. 54. Ooh, it says 54.94. So it's 54.9 to round to the nearest tenth. Okay. All right, I think I did one more just because. Okay, take a look at this one. What sides did they give me? They gave me adjacent and they gave me hypotenuse. So, toa. Adjacent and hypotenuse is the cosine. So you're going to write the cosine of 28 equals x over 11. You want to solve for x, we need to get rid of the 11, multiply, and then feed that into the calculator. That's all you have to do. You go 11 times cosine of 28. Done. 9.71, which rounds to 9.7. Okay, next. Okay, now you're going to be using it to solve. You're going to be using trig to solve a right triangle. Now this is one of the how do I say it? This is one of the skills that I want to make sure you know how to do. Okay, this is going to be worth a quiz score and bigger than just a problem. My typical test for this chapter would be solving 3 different triangles, and that's it. Okay, just solving triangles. And then maybe, actually, that's not true. Solving triangles and then do 1 law of sines and 1 law of cosines, which we haven't hit yet. But solving a triangle means to find all angles and sides. So you have to be strategic here. You have to look and say, what did they give me? Okay, look at what they gave you. They gave you 1 side, and it is the hypotenuse. They gave you basically both angles. So you could find this other angle right away. It is 43, right? Because the 2 add up to 90. So that would add up to 90. Okay, so now you get to choose. You can either stand at A or you could stand here. I'm going to stand at A because they labeled it. So I'm like, okay, I'll just hang out here because I can. Okay, now think about this. You can't do tangent because you don't have opposite or adjacent. Okay, so you got to pick one of the other ones. Okay, so I think what I'm going to do is sine first. So I'm going to use sine to find A. So I'm going to go sine of 43 degrees is equal to A over hypotenuse, opposite over hypotenuse, 21. Multiply both sides by 21, and you will get A is equal to 21 sine 43. Okay, round to the nearest tenth. You plug that into your calculator, 21 times sine 43, 14.3. Round to the nearest tenth, it said. Okay, so A is 14.3. Now look at this. You guys have a choice here. You have 2 sides of a right triangle. You can use Pythagorean theorem. I could go B squared plus 14.3 squared is equal to 21 squared. B squared equals 21 squared minus 14.3 squared. Or B is equal to the square root of 21 squared minus 14.3 squared. Okay, you can put that into your calculator. Or you can use trig. Let's say you just are more comfortable with trig than you are with the Pythagorean theorem. Then instead you would use cosine or sine. I mean, cosine or tangent, it really doesn't matter. I'm going to use cosine. I'm going to say cosine of 43 is equal to B over 21. Multiply by 21. And now B is equal to 21 cosine 43. 21 times cosine 43. 15.4. Okay. 15.4. I want to show you though, there's one thing that's interesting. So I find these sides, right, with trig. So this is using trig. When I do this one, it's 21 squared minus 14.3 squared. So let's do this. Square root of 21 squared. Wait. I can't seem to get that to work. Hang on. 21, get up there. I can't do it. Why is it not doing it? I want it to do, there it goes. I don't know why, okay. 21 squared minus 14.3 squared. Okay, look, you get 15.4. Hey, that actually is the same. Oftentimes they differ by 1/10. They hardly differ by more than 1/10, okay? So my only thought is that be careful with Alex because I'm feeling, I don't know if they picked particular triangles that match. I don't know if they're giving you a little bit of leeway in case this was a 0.5. You might need to tell me if Alex is pushing trig or Pythagorean. Either one should be acceptable, you guys. Okay, next. Just do not actually solve until the very end on the Pythagorean theorem. Don't round off any intermediary steps, okay? Here we're going to solve this again, okay? So look, we have 50 here, okay? And look, it's basically trying to tell you to do B. Now, I could do 40. B is 40. Okay, I could also do 50, you guys. I could be a rebel and be like, don't tell me where to stand, bud. Okay, I can stand right here. I'm going to call this A. Okay, and I'm going to do it from A because I feel like standing on top right now. Okay, so what relationship do I have? What side do I have? Start naming them from A. I have adjacent, and then I don't have opposite or hypotenuse. So I'm going to use trig to find the opposite and the hypotenuse, but I have to use the adjacent because that's a known. So I'm going to go, let me use what's adjacent. So nope, no adjacent there. Ka, that works adjacent and hypotenuse, and toa. Tangent works too because that's opposite and adjacent. So I'm going to go cosine of 50 is equal to A over, not A, cosine, 28 over C. Multiply both sides by C to get it to the top. Divide by the cosine of 50, okay? I'm actually going to write it again, just because. Divide both sides by the cosine of 50. Okay, so C is equal to 28 divided by the cosine of 50. 28 divided by cosine 50. You can see when you hit cosine, it's waiting for the angle. So that's 43.6. So you get 43.6, all right? Now I'm going to use tangent of 50 to solve for A. By the way, once I found C, I could use sine and do opposite over hypotenuse. I'm just going to use the 28 because that's what they gave me, and I didn't round to get the 28. So tangent of 50 is equal to A, opposite over adjacent, multiplied by 28. So it's 28 times tangent of 50, 33.4. Okay, so A equals 33.4. Now you've solved the triangle. We have every single side. Okay, and if you wanted to check it, you could do 28 squared plus 33.4 squared and check to see if that's equal to 43.6 squared, just for the fun of it. All right, let's try another one. I have one more solving triangle. Okay, so here's my angle. Let's find B. Oh, I know why they put the B there. They're not trying to force us to sit there. It's because you have to actually name that angle. So it's 43 again. Okay, you have to name that angle. They're going to ask you like angle B, and you have to put in 43 degrees. Okay, and now we need to find C and B. I'm going to use 47. I'm going to just sit here. Oh, okay. All right, and we're going to go opposite. I have the opposite. So ka, toa. So the two that have opposite are sine and tangent. I'm going to use the sine to get C. So sine of 47 degrees equals 15 over C. Multiply by C. C sine 47 equals 15. Divide by sine 47. And then you get C is equal to 15 divided by sine 47. 20.5. Okay, then I'm going to use trig. Again, you could use, if I got 20.5, I could use Pythagorean theorem at this point. Okay, b squared plus 15 squared equals 20.5 squared. Or I can use trig. I'm going to use trig, and I'm going to use tangent. Tangent of 47 degrees is equal to 15 over b, opposite over adjacent. then I get B tangent 47 equals 15. Divide both sides by tangent of 47. You'll notice I'm actually showing my work, and the reason why is because you guys aren't that familiar with the tangent, cosine, and sine, and I just want to make sure we always keep that angle with the function, okay? So it's 15 divided by tangent of 47. 15 divided by tangent 47 equals 13 point, ooh, that's going to round up to 14. 8 rounds up to 9, the 9 rounds up. So that's going to round up to 14. Okay, so B is approximately equal to 14.0. When they say the nearest tenth, oh, that's really important, you guys. When they say round to the nearest tenth, they mean round to the nearest tenth. That means you actually have to list it. If you were to just put 14, you probably would get it wrong. It has to be 14.0. All right, and that's how you solve the triangle. We found every angle, we have every angle, and we have every side. And that's it.